Today we're doing 5 theorems about roots of polynomial equations, day 2. Our learning goal is the same as day 1, that you will be able to solve equations using the rational root and the conjugate root theorems. So today we're going to look at the conjugate root theorem. And basically it says that when you have conjugate roots, that means if you have something like a root in this form, which means it's going to be irrational, then its conjugate will also automatically be a root. And that's because we use plus and minus when we're square rooting a negative number. Okay? So the conjugates come in pairs. Okay, so another example is if you have 1 plus I as a root, then 1 minus I is also a root. So they always come in pairs. Okay? Or if you have square root of 2, then negative square root of 2 is also a root. So just remember that it's always plus and minus. Okay? And if you had to write the factors, so if you had a function and they're telling you that or equals 0, and they tell you that the roots are -4 and 2i, well, -2i is automatically one of the roots. So that means this degree has to be 3 instead of 2. So when you write out your factors, it's going to be x plus 4 x minus 2i and x plus 2i. And then you would FOIL it like before to get your polynomial. So I'll actually FOIL this out on the next page so you can see how it looks. Okay, so I'm going to continue that example from before. So we have -4, 2i, and -2i was the one that wasn't given. But since the imaginary numbers come in pairs, then we know that it has to be one of our roots. So when you write your function, you're going to first write them as factors. So we have x plus 4, x minus 2i, x plus 2i. I would suggest you FOIL the imaginary numbers first. So you're going to get x squared plus 2ix minus 2ix minus 4i squared. Well, the middles should cancel if you did it right. Don't forget that negative, or I squared equals -1. So -1 times -4 is +4. Then you want to FOIL it by your next term. So you'll get x cubed plus 4x squared plus 4x plus 16. There's nothing to combine, so this is your polynomial function. Okay, Descartes' rule of signs. Descartes was a mathematician that came up with a way to help us when we're trying to figure out the roots, and you have a number that has a lot of factors. Well, This French mathematician came up, or he noticed a connection between the roots of a polynomial equation and the plus and minus signs of the standard form. So I'm going to use this example. Okay. To find the number of positive real roots, these are only for real. Positive real roots. You count the sign changes like they are. So from here to here, that's a sign change. That's 1, 2. So that means that there are either 0 or 2 positive real roots. So you know how you make your list? That's telling you that there could either be 0 or 2 positive real roots. Then to find the negative real roots, what you're going to do is you're going to plug in negatives for all your x's. So that'll be negative x cubed minus negative x squared plus 1. So if you do negative x to the third power, it's going to still be negative. If you do negative x to the second power, it comes out positive. Now you count your sign changes. So from here to here, no sign change. From here to here, that's a sign change. So that means that there is only one negative real root. And the way that it works is it's either equal to the number of sign changes or it's less than that by an even number. So if you did 1 minus 2, that comes out to be negative 1. So that's why it'll only have one negative real root. The reason why it worked for the positive is you do 2 or you do 2 minus 2, which gives us 0. So it's always less than that by a positive number. So you always subtract 2 from that number. Okay? Now, you also have to realize now the 3 means that there are 3 actual roots. So if there's one negative, then the other 2 have to be positive, or the other 2 have to be imaginary. Okay? So then we'll try another one. Okay, so we're going to use the rule again. So first, to find the positive real roots, we count the sign changes like they are. 1, 2, 3. Okay, so 3 or 3 minus 2, which is 1. So that means there are either 3 or 1 positive real roots. I better write it out for you guys. Okay, to find the negative real roots, remember you make all the x's negative, or you plug in negative. Only the x's do you change. So negative x to the 4th power is positive. Negative x to the third power is negative, but two negatives become positive. Negative x to the second power is still positive. And then we still have our minus 1 at the end. So now I'm going to count the sign changes. From here to here, no sign change. From here to here, no sign change. But from here to here, there was 1, which means there is 1 negative real root. So I basically look at Descartes' rule as a way of helping you when you're trying to figure out which of my possible or my list of possibles should I try. Okay? Okay, so we're going to put everything in perspective that we have just done or learned about, and I'm going to find all the rational roots now. Okay? And these are only the rational roots, not the imaginary. Okay? So, first you start with your possible list. So I'm going to do factors of 15, because that's my constant, over my factors of 6. So my list will consist of plus or minus 1, plus or minus 1/2, 1/3, 1/6. Then plus or minus 3, 3/2, 3 over 3 we already have, 3 over 6 we have. Then plus or minus 5, 5/2, 5/3, 5 over 6, and then plus or minus 15, 15/2, 15/3 we already have, and 15 over 6 we already have. So that's my list of possibles. Okay? Then I have to figure out which of these should I try So I'm going to try negative 1/3. This where Descartes' rule will help you because you can go through and figure out how many positive you'll have. Let's see, you have 1, 2, 3. So three or 1 positive. So I'm going to try negative 1/3. Okay, so negative 1/3 of 6 is negative 2. And then you add going down. Negative 1/3 of negative 15 is 5. And then you add going down. Negative 1/3 of 18 is negative 6. And then you add going down. Negative 1 times a negative 45. Negative 1/3 times negative is positive 15. And you add going down. And that means negative 1/3 is one of our solutions. So then you write your polynomial back. Remember, you're going to lose the term since we divide it. And remember, the 4 tells us there are 4 actual roots. We found one of them. Then we look to see if we can do grouping, because there are 4 terms. Let's try it. It may or may not work. So I'm going to take out a 3x, and that leaves 2x minus 5. And then here, they have a 9 in common, and that'll leave 2x minus 5. Oh, it works. So my factors are 3x plus 9 and 2x minus 5. And actually, with this one, I could take out a 3. Which I should have did first anyway. So that would leave me with x plus 3 equals 0. And 2x minus 5 equals 0. So x would equal 5/2. Oh, I'm sorry. I was supposed to take out a 3x squared. Ooh, bad mistake. Oh my goodness gracious. Sorry about that, guys. So then we subtract 3. And we square root. And look, we got plus or minus I root 3. This is not a rational number, it's irrational. So we can't use this solution because it said find all rational roots. So my only rational roots are negative 1/3 and 5/2. And then you're done. So if it says rational, you cannot use irrational numbers. Square root of a negative number is irrational because you have the imaginary number I. And that's it.